Hello, everybody, and welcome to Unit F, where we will talk about document databases, specifically MongoDB. So what's on the agenda? First, we'll discuss what is a document database, give you a little background on how these came to be and how they work, how they're used today, and why they're so popular. We'll look at the comparison between the relational and the document model. What's important to understand is that in the document model, you can make any database you want. So if you can make it in relational, you can make it in document. It's a fully CRUD supported data model, and you can create a wide variety of applications in the document model. Now you're going to have some concessions, as we're going to see, but concessions aren't bad. We'll explain the MongoDB architecture, that is, how does it distribute data, how is it fault tolerant, all the things that you need to worry about in big data scale. Then we'll look at the MongoDB data model. How does it do what it does? What's the equivalent of a table? What's the equivalent of a row in the table, etc. And we'll learn some Mongo query language along the way. And we'll talk about how you can use drill and Spark with MongoDB using the Spark connector and the drill storage plugin. First things first, what's a document database? What is this all about? So a document database is designed to store semi-structured data. Normally it's going to be in JSON format. It could also be in XML format. The MongoDB platform really emphasizes JSON as its document format. The semi-structured JSON data is the document. So we have full CRUD support. You can create a document, update a document, delete a document, read a document. One of the things that's kind of limited about document databases is how they do updates, as you'll learn. Some document databases do not support partial updates. That is, you must read the entire document and then write the entire document back out. When you think about this, this can be a little bit of an issue, especially when you have a very large JSON document that you're writing. If you're going to write 54K of data just to update one small attribute in that document, this can be a little problematic. But this is why you need to think about the design and intent behind the data that you're storing in any of these databases. And that's why they all exist. No one database solves every problem. So it's about picking the right tool or the combination of tools for the job. Documents are stored in what are called collections. And these collections, like just about anything else that we have out there in the database world, are fetched by a key. So there is a key that you can either set, or you can have what's called a surrogate key, like we learned in the other relational database class, IST769. You have this surrogate key that is generated by the system. And the keys must be unique to the collection, just like the keys must be unique to the table. And so in a way, a document database is a lot like just any other database where you have to reference the data by its key. Document databases tend to be heavily indexed because we end up building this document and we want to kind of like access the data in a wide variety of ways, and we don't want to do that inefficiently, so putting indexes on there is really important. What we learned about indexes before, way back in the other class, is that when you have an index, you're making a concession. You're writing data additionally, like more than once, in exchange for rewriting it in a format that's more conducive to the queries that you want. And this is okay. This is okay. Storage is cheap. Processing is not. We'd much rather invest in additional disk space and writing data multiple times. Now, where indexes kind of fall apart, as we all know, is when you have too many indexes and the writes slow down, because if you have 10 indexes, you have to write the data like 10 times. Okay, that's neither here nor there. We'll get into all this stuff. So let's talk about some popular document databases. We have the AWS Document DB, Google Firebase, MongoDB, CouchDB. Azure has something called Cosmos DB, and those are all like Google and AWS and Azure. They all have a document DB in the cloud. You can also use Mongo and Couch. You can install those yourself, and they also have versions in the cloud as well. So The typical document data model looks like this. You've got this database, you've got this collection of data, which is a subject area of documents, and then you have the individual document. And these documents are nothing more than a JSON file. So here's a great example of a document that we would have in a document database. You can see I have these fields or keys or attributes as they're known in the document model. I have attributes here, and then the attributes have a colon and then a value. This is pretty much the JSON format. And then attributes can be nested. So I have name first, Michael, name last, Fudge. And we are okay with nested data. We are also okay with attributes that have lists of other values. This is totally acceptable and embraced in the document world. We have this tree-like structure, like you see on the right, multiple keys and value pairs, like name, first, Michael, email, the first email, mafudge, second email, mafudge@gmail.com. Documents consist of composite data. They tend to be describing. You don't need to build or set a schema. You just put the data in there, and then when you ask for the data out, you request a field like first name dot first. If it's there, great. If it's not there, you get null. Okay, very similar to how the Hadoop world works. You ask for something and it's not there, you just get back null. There's no fixed or rigid schema here. This is good for, you got data you need to sock away, right? You just have data and you want to guarantee that you write it. You want to guarantee that you can read it. You don't really want to make a table first. You just want to be able to dump it somewhere. So programmers love document databases because it gives them the opportunity to be really kind of lazy and just say, save this stuff. And because the world is kind of working in the JSON format, this is another reason why we like document databases as programmers. It makes it very easy to take our data that we get from a web API, which is usually in JSON format, or if we're using Python, it's very easy to serialize our objects back to JSON format and then write them to a document database. So a lot of programming languages are friendly with document databases. When we ask for an item, we get the whole thing. So you might ask for every person that has the name Mike, you get back 7 of these. Each one is the entire document. You can ask for parts of the document out, but usually what will have to happen is the document database itself will have to retrieve the entire document before it does the column projections. What are some use cases? Content management systems, product catalogs, any kind of immutable data that's out there, like a history of orders. It's great for representing hierarchical and heavily nested data, like you could put a course catalog in a document database. That would be a great application of a document database in an academic setting. I don't know if I would want to put registration data in there so much, but you might put the once the registrations are immutable, like the semester's over or the grades have been posted, you could store that in document form if you want. It's not good for data that has really complicated relationships, like you've got just a bunch of things going on, like graph-oriented data and things like that. Like you might have this course has a prerequisite of these courses, and then that course is in this major and it's taught by these individuals. You can represent that in a document, but then you lose the cross-cutting concerns. Like, do I want to search by course? Do I want to search by prereq? Do I want to search by topic? Do I want to search by who's able to teach the course? You lose that because you have to store the document in a very specific way, as you saw from this over here. You have to store the document one way. And that sort of reduces your options as far as just getting the data out in a variety of ways. Not so great, even though you can retrieve part of the document. In reality, this is you have to retrieve the whole document and then do a projection. So this can be a performance issue. If your data is changing a lot or parts of your document are changing a lot, you don't want to use a document database in an example like that. You want to think about something that's more tabular, maybe even wide column instead. Programmers love document databases. That goes without saying. Easy to read. The document format is supported by many programming languages. What you see here is some actual code that is in Python, and it writes to a document. And so I'm just going to kind of go through this. So I'm importing the library here on line 1. This is connecting to the MongoDB client. Normally in here I would put the URL and the connection information to get there, but I left that out. And then what I'm doing is I'm asking for a collection of documents from the database. And then I'm making, this is just Python code here. I'm just making a Python object. And then in here, I'm saying, hey, let's take the products collection and let's insert one of the products here. So this is a Python object, and this here is a document database object. And that would in turn put the thing in the database. I don't have to know any SQL as a programmer. I don't have to deal with keys and foreign keys, and it's just awesome. Where it's not awesome is if I want to retrieve back all the products that are sporting goods. Okay, that requires a little bit of mental exercise in a document database, or it requires me to build a custom index. So that's the downside of it. Let's compare the relational model to the document model. The relational model is designed for use by DBAs, right? So there's a person that designs the table schema after consulting with the end users, and then that schema is rigid. And there's someone that administers the database and outlines who can do what. We have a complex data model. It's highly normalized, lots of tables, right? Lots of foreign keys, flexible, performant queries. You can slice and dice in a variety of ways. If you have your data in relational and it is normalized, you're in query nirvana. There's 101 ways you can get the data back out. That's what we like about relational. We store that related information in other tables, right? And data redundancy is usually not something we do in relational. And we have SQL as a language. In document, you design for, it's more for programmers or developers. It's not for database administrators or business analysts, systems analysts. This is definitely a developer's database. The data model is incredibly simple. It's denormalized. The queries will not be as easy to do without creating a series of indexes. We store the related information not in its own collection, but within the document itself. So you embed the data. If you're storing like a customer, you might store the orders with the customer, for example. And redundancy is expected, and we have a different query language that we must use when we do document. We can't use SQL. Now you're going to see when you get to drill, you can use SQL over anything. Yay, right? But it's going to treat it like if it were just reading a JSON file off of an S3 bucket or something like that. It's going to treat it like that. So here's a review for you. Here's the concept of a customer, the relational way, right? So we've got, we've got customers, and they've got names, emails, and phones, right? And one customer has many phones, so I've got a table over here for each phone, and then I got a table over here for each address, right? And this is actually a bridge table over here, right? Because one customer can have many addresses, and then one address can be, the same address can be for many customers. Like my wife and I are customers, one address, many customers, my wife and I. I can have 3 addresses: Mike Fudge, work address, home address, business address. And then there's a lookup table over here to postal code. So this is not uncommon. Customers have many entities like phones and addresses. You can update phones and addresses independently, right? You can insert here and not have to mess with the customer because of the primary foreign key relationship. This is in third normal form. We kind of beat this into your head when you take IST 359, 659, right? The intro to data, relational database classes. You really learn that you want your data, your tables to do one thing, right? So your table should just do one thing and one thing only. And then what you have are keys everywhere. Foreign keys all over the place, primary keys everywhere, right? And you see the foreign keys are always on the many side here of these relationships. So let's contrast it to the document way. To the document way, all the things you see on the screen here will get stored into one document. And we would nest that data. So here's this customer, and then here's the 2 phone numbers for that customer, and then here's like one of the 5 addresses for that customer. And we just embed things like that. And it ends up being self-describing, ends up being denormalized. The data integrity now shifts from data logic, right? When we had those tables, we had referential integrity and stuff. We don't have referential integrity here. What if I insert the same phone number again? Oh, well, it's in there twice, right? So now the data integrity responsibility is on the programmer. It's business logic. It's no longer data logic. There's very little data logic, if any, in a document database. There just isn't. You are completely selling out on data logic. Much easier to store, a little more difficult to query. For example, do 2 customers have the same address? Well, I would have to retrieve every single document and then look through the list of addresses at street and see if they match, right? That's a lot of effort, as opposed to if I did it this way, I can just query this table and see if there's 2 streets that are the same, right? Or maybe I can query this bridge table and see that. Okay. There's lots of ways I can do it. Okay, let's discuss how you design for the document database. ER modeling is going to work. You're going to find that in this class, when you design for document or you design for graph, or even to some degree wide column, ER modeling is going to work a little bit. It definitely works here for documents, okay? You're going to create an ER model, and then you're going to look at each entity and you're going to ask, is that entity reference-oriented? Or is that entity process-oriented, right? And remember, reference-oriented data are your nouns, like people, places, things. Process-oriented data are your events, your business processes, like ordering something is a process-oriented data, or paying a bill, or registering for a class, right? Reference-oriented data are things like students, or products, or customers, or vehicles. These are all reference-oriented data. Process-oriented data, reference-oriented data, airport, airplane. Process-oriented data, flights. Okay. So we want to minimize the number of entities and relationships by taking the reference-oriented data and any lookups and folding them into one document, and then taking that process-oriented data and deciding whether or not we can embed the reference-oriented data in there, or we should have what's called a pointer, which is a reference to the ID of the reference-oriented data. Okay, so if you have process-oriented data like flight, and then a flight needs an airplane and a flight needs an airport, two airports, a from airport and a to airport. If you do that in a document database, your choices are, do I embed the airplane and airport information right into the flight process-oriented data, or do I have the airplane information just have an ID, and that ID will allow me to make a second read to go out and then get from an airplane's collection the airplane or the airport? You have to sort of make that decision, and it really comes down to how many additional reads do you want to do. If you want to do this all in one read, then you should embed everything into one document. Okay, that's not going to be good for updates. All right. If that data is immutable, though, it doesn't matter. You're not going to update the flight. Like if you're storing flights that already happened, not flights that are happening, then it doesn't matter if it's stored as one huge document, because the plane was used, the airport was used, and the other airport was used. While the flight's taking place, the document database is not the place for this data. It's just not. Okay. So let's talk student enrollment. We've probably done an example like this relationally many times. Each entity has an example would be an example of a collection. So you got a student collection, a course collection, and an enrollment collection. Or what you could do is just make one collection called enrollment and embed student and course in it. Either way, it works. You just have to figure out if there is some necessary reason that the same student might be in enrollment twice. You know, two different enrollment documents reference the same student, and that matters to you. If the enrollment is a snapshot at a point in time and doesn't change once it's added, then certainly you would embed the student and the course information right into enrollment. That's the document way. Okay. So again, you want to focus on your process-oriented entities and then decide, can I, they're usually on the many side, and then decide, can I take this thing on the one side and just embed it in there? And it really comes down to, does this update? Are we changing this? And what are we changing? Like if we're just changing attributes in here and not attributes over here, then we can embed it. If for some reason we chose document and we're changing attributes here and changing attributes here, then you have to reference it. But you want to avoid doing that. You want to avoid referencing. And what you would do with the references in enrollment, there would be something called student ID, and it would actually be the ID of the document in the student collection. That's the way you do it. Let's dive into the MongoDB architecture. So MongoDB is a document database. It has this hierarchy of database to collections to documents. Documents are JSON schemas. It uses what's called a single master architecture. As we learned before, this involves having a lead node or a couple of lead nodes that tell us where to write things and tell us where to go to read things. It supports consistent reads, and it scales well horizontally. It uses what's called sharding and data replication, which we'll talk about a little more. And the data model is pretty simple. You have database, document, collection, and you can write to any database, even ones that don't exist. You can write to any collection, even ones that don't exist. You're writing a document and you're saying, here's the database, here's the collection, and it doesn't matter. If it's there, great. If it's not, it'll just make it. MongoDB is pretty flexible like that. And it has a custom query language called MQL. It is not like SQL. It is actually based on JavaScript. Let's talk about how MongoDB scales. So there's two key concepts here that we need to look at in more detail. One of them is sharding. Sharding is the process of taking a data set and then splitting it up, usually on what's called a partition key or a shard key. If you don't specify a shard key or a partition key in any database, what ends up happening is it will usually generate a hash from either the data or a chosen key for the data, and then split the data up that way. If we want to be very specific about what goes where, we should specify our own shard key or partition key. So, for example, you might store student data in a document database, then shard the students by their major. And so that way you're guaranteed that all of the accounting students are located in the same physical place. And all of the biology students are located in the same physical place. Does that matter to you? I don't know. That's ultimately what you need to figure out as part of doing the design. It's just understanding the shard strategy is important. So the data, again, is distributed to nodes based on the shard key strategy. Okay. Does it make sense to have all of your accounting students on one node? Well, yes, because now you're going to be able to read them without involving too many other nodes in the cluster. And this is kind of an important facet of doing distributed data, is we want to sort of avoid asking too many nodes to participate in the read or write process. So what is a replica then? A replica is a synced copy of a shard. So each replica contains the exact mirror of what's on the shard, and we do this for fault tolerance. So again, going back to the student example, let's suppose I have a 3-node cluster, and I write all of the biology students to node number 1, and I say there are 2 replicas of that shard, then those biology students are also on node 2 or 3 as a backup, if you will. As a backup. So let's think about it again. You have a data and you have three shards. You can split those shards up to individual hosts. So now my Mongo cluster has 3 nodes, or host 1, host 2, host 3. Each host is holding a shard. What's in the shard depends on the shard key. If I don't specify a shard key, it's going to have some of this document, some of that document, some of that document. Whatever we shard on, we want to make sure that that shard is well balanced. We don't want to be in a situation where, host 1 has like 99% of the data, and then this has 0.5% and this has 0.5%. That's not good balance. We want to make sure our shards are balanced. So the shard key determines where the data goes. So there's 2 ways you can do this. You can specify a range or a hash. Since we want even distributions, we need something that will do that. So the hash key will always give you even distributions. Let me move my fat head out of the way. The range key it allows you to take something that you're sharding on, like maybe an integer, and say if the integer is between 0 and 10, put it on shard A. If it's between 10 and 20, put it on shard B, and if it's 20 or more, put it on shard C, and that way you can balance the shards out that way. Again, the goal here, without getting too in the weeds, is to make sure that our data is split amongst the nodes in the cluster. All databases have a feature like this. It's either called a shard key or a partition key. And if we don't explicitly state how that rule should be done, how that data splitting should be done, it will create a hash out of our key, which pretty much says, okay, which bucket do you go in? Okay, here. Which bucket do you go in? Here. Which bucket do you go in? Here. Which bucket do you go in? Over there. And it just more evenly distributes the data across the shards in the cluster. So now that you've got your shards, you can do your replicas. And this example has 6 nodes in the cluster, 1, 2, 3, 4, 5, 6. And host 1 has shard A, host 4 has a copy of shard A. Host 2 has shard B, host 5 has a copy of shard B, et cetera, et cetera. This is how Mongo does it. Other databases, you can store replicas on the same host for efficiency. So, other databases that will learn, I'm looking at you, Cassandra, you wouldn't need to do it this way. But because Mongo is a consistent database, it must be done this way. And here's how it factors into consistency, right? When you come in here and you're going to read, and you're coming down here, somebody says, oh, that's on host 3. Goes over here. If host 3 croaks, then it's on host 6. Okay, there's never a situation where we need to sort of figure out what host it's on and hope that that host has the most current copy of the data. That's never going to be an issue because of the way that MongoDB does its thing. Okay, let's talk about the various ways that you connect to MongoDB. It's, like I said, it's a programmer's database. You can connect through the Mongo shell, Mongosh, and it's a direct connection. Then from there you can execute MQL commands. You can also use an ODBC or JDBC driver. And then from there, you can query it like it's some kind of table or a tabular-like structure in your favorite BI tool. You can use Drill or Spark. Either of those work. There's also a web tool called Mongo Express, which allows you to access the database and see collections, see the databases you have set up on the cluster, see collections, things like that. All right, let's do a demo. In this demo, we will connect to MongoDB, and we'll also show you all of the other goodies that we have set up in our Mongo environment here that are particular to this class. And then lastly, we will connect to the Mongo shell from the command line down here. We'll do that. All right, here I am out at my command line in the Advanced Databases folder, and if I do my Docker Compose PS, you'll see that I've got a couple things running here. I know it's hard to see. Let me zoom out a bit. Okay, I've got Mongo running, and the Mongo app running, and Mongo Express running. And here are the ports things are running on. So first things first, let's just sort of check out what's happening here. Let's go to that Mongo Express server. I'm going to fire up a browser here. And if I go here to this site here, there's Mongo Express. These are all of the databases that are set up. The admin database is there by default. Admin and config are just there. These other ones I made. Yours is going to look differently. These are just ones that are out there. If I go into like this demo database, you'll see collections. And here, these collections I got by running, if I go to Jupyter and I open up that MongoDB document right here, this F document, and I run this Spark code here, and then I run the sample data code here, you'll see that it loads things into that Mongo demo database here, okay, using Spark. And I know you don't have to really look at it right now. I'm just showing you how they got there, okay, in case you want to put them there as you're following along, right? So you'd have to run this guy here first and then run this guy, and it's going to insert that data in here. And so this is a collection, for example, Europe. And if I go here to view, I see a bunch of documents in that collection. And, you know, it's not really an ideal way to look at the data, but you can look at it. You can also search the data here using queries and stuff like that. I really strongly discourage you from doing this. Learn how to do it using the Mongo command line, and you'll appreciate it so much more. So another thing I wanted to show you is that there is a app here called the MongoDB example. And this is a great example of why programmers really love MongoDB or document databases in general, is you can modify the schema in code and not have to worry about the database, right? It's Mongo is going to just do what it does and write what you ask it to write, and it doesn't care. So, for example, as a programmer, I make this form. You know, it's like a feedback form, right? And people enter their email. I'm going to put in like bob@company.com. And I'm very satisfied. And I'd like to sign up. I don't want to sign up for your mailing list. And then I'm just going to put in here nice product. And put that in there. And then later on, your marketing department says, can you change the form around, add a couple of fields? In the relational world, you're now altering a table, right? Adding some columns, this and that. Then you're rewriting the code to handle the new schema. In the document world, you just go right to the code and update the UI accordingly, and then just write a new document with a different schema, because the document model doesn't care that one document in the collection and another document collection aren't even alike. It doesn't care. So I'm going to put in like bob@company.com. Again, I purchased some cheese and I'm very satisfied. Now see, it defaults with it's checked for mailing list, whatever. And then I'm just going to put in another comment. So this is a completely different schema. But the way the document database works is it just doesn't care. It just doesn't care. If I go here to feedback, and I have bob@company.com, right? Very satisfied, nice product. And then if I go over, see, this one says purchase cheese, and this one has nothing for purchase. Sign up mailing list on, nothing. Because These columns don't exist in the first iteration of the document, but in the next iteration of the document, they do. So if you have attributes that there's just nothing in common, the document database is totally okay with that. It doesn't really discriminate against that at all. And that's what kind of makes the document database so special, is that from a programmer standpoint, you don't have to manipulate your database at all. You just tell it what to write, and it writes it. Now, on the flip side, where this ends up being a problem is you can put, I don't know, product information in the feedback collection on accident or on purpose. I don't know. And it'll really kind of muck things up. So you have to sort of think about that. There's very little, and we're talking little data integrity at all in this model. It is what it is. So let's go look at this from the command line now. Let's figure out how to connect to Mongo from here. And what we're going to say is docker compose, and then we want to execute in the Mongo container the Mongo shell. Now that's not enough. If you just do that, it's going to connect, but it's not going to log into the database. So the Mongo model has to at least have a username and password. Excuse me. So I think we set this up with username admin and then password Mongo PW. And then I think I need to specify the authentication database too. Why do you have to do this part? Well, admin is a collection, is a database that has a collection of usernames and passwords in it. You can actually, in MongoDB, configure it so that the usernames and passwords are not stored in Mongo, but stored somewhere else. Like they can be stored in, I don't know, Google, for example, as part of the Google auth. You can sign in with Google, that kind of stuff. And if things go well, there I am. I'm in the Mongo shell, and I can do help, get some help. I get this kind of stuff. I can say show databases, and I get, there's my list. And just to kind of go full circle here, if I use demo and then show collections, let me clear this up a bit just so you can see it better. If I show collections, there's my feedback, right? And then if I do this, I can say DB feedback. Yeah, and let's take a look at what we got here. Whoop. I think it's fine. I'm find. Sorry, find. That's what happens when you have so many databases that you have to remember how to do. You forget how to do certain things in certain databases. I mean, this class covers like 8 different databases, 9 different databases, and boy, it gets confusing at times. So here are my 2 documents that you saw here. Right, there's my 2 documents. Here's my 2 documents. And you can see what happened here is I have different attributes. Like this one does not have other comments, or this one does not have sign up mailing list. This one doesn't have it. This one does have it. So it just gives you an idea of how this stuff works and how it comes together. Now these 2 documents could be, they don't even need to look the same. Like they could be, this could have like email satisfied, and this one could have like car license plate. It doesn't matter. That's the good and bad of document databases. They just do not enforce a schema at all. This is not enforced. Let's start learning some of the Mongo query language. So you saw me demo some of this already. Use database, show collections, see what collections are in that database. They're like tables, right? You can also use db.collection name, insert one, insert many, and find. So find gives you the information back out. These allow you to add data to it. This is going to be JSON data or an array of JSON data. And I can demonstrate this, I'm sure, in a bit. So again, let's talk about data integrity. Document databases are incredibly flexible. They do not complain about any missing schema. No database, I'll make that for you. No collection, I'll make that for you. Enter the same thing twice, no biggie. I'll just pick a key. Don't worry about it. I gotcha. Add people to the books collection. Whatever, dude. I'll do that for you. I don't care. You are responsible for data integrity. These are incredibly simple databases, and they're simple on purpose. And so if you have some expectations, I suggest you throw them out the window, because you're going to realize quickly that you can do whatever the heck you want in these databases. So let's go and do a demo. So what we'll do is we'll make a cars collection and then throw some cars in there, and then get some results back from the database. Okay, I'm back out here at the Mongo command line for the Mongo shell, and I'm in the demo database already. So I did use demo. And I can, like, by the way, if I show databases, this is really interesting. And there is no mic, right? So I can say use mic, and like, poof, I'm in the mic database. It doesn't even exist. I'm in there. Nothing really happens till you add a document to a collection. Once that happens, poof, now it becomes real. Up until this point, it's just like in the ether. Very weird. So I don't have a cars collection. You see there's no cars collection in there. So I can't say create collection cars. That's not how it works. If you want to use the cars collection, you just start dropping stuff into it. So let me just show you. If I do DB cars, and then I just throw in cars, I'm going to say insert one. And then I'm just going to put in this name Mike. I'm going to show you a couple things here. That's not a car, by the way, but it doesn't matter. Okay, got inserted. If I do DB cars find, it'll give me everything that's in there. And then there it is, my one object. Now, just for grins, I'm going to go in here and I'm going to insert one, and this one's going to be called, just show you a different way you can do this. You can do name like that. You don't have to put the first one in quotes. This one you should, because it's data, right? But now instead of name, I'm going to say age 50. See, I can put whatever the hell I want in the document database. It just does not care at all. The schema does not matter. There is no schema. And cars doesn't exist until I do this. All right, so now let's go ahead and add some real cars, and we'll deal with this other data later when we learn how to delete stuff out. So let's add some cars here. Let's do insert one, and then, I don't know, make Chevy, and then model, and let's do cruise. We're gonna do a couple of these. That's good enough for now. See, this is JSON data here. This part here, JSON. Okay, inserted. Let's add another one, Chevy. Let's add Aveo. And let's put in another attribute in here, like color blue. Doesn't matter if we have the attributes or not. The document database don't care. So here's my two bummer objects, and then here's some actual cars. You can also add a bunch of things at once by giving it a JSON list. I can say insert many, and then what I'm going to do is I'm going to make this multi-line. So I'm going to start a list, and then I'm going to insert make Chevy, model, traverse. Let's do like miles per gallon. I don't know, let's make something up here. I don't know. Let's skip miles per gallon for now. And let's add another one. Make Chevy model tracks. And let's do an MPG now. We should probably do something. I don't know. Let's do like 30, 34. I don't even know what it is. And then that's my second document. And then I close out my list of documents and then close out my insert many call. And then I inserted 2 objects. And if I find them, now I have these 4 cars. And I also have 2 other documents that are just utter trash that I don't want in here. Okay. Now, if I just want, let's add one more. Let's let's go through here. Let's do insert 1, and let's add a different car. Let's add the make Honda, and then the model is a Civic. Let's do that. And then it's like, oh crap! I meant to put miles per gallon on that Honda Civic, right? Mongo don't care. It's just going to keep inserting data. Honda Civic's in there twice. So you might say, well, how do I update that? Or how do I tell it that I want to update that? Well, we'll get to all that. Okay? Just understanding the basics of the document model is really important. So let's just cover one last thing. Maybe you don't want to retrieve all of them. Maybe you just want to retrieve the Hondas. Okay? So you can say find make Honda. And you can use the JSON to query the JSON. See that? So I'm just saying, hey, find the Hondas, and then I'm actually using that JSON to do that. Okay. Now, if you want to find things like, you know, over 40 miles to the gallon or something, that's different, but we'll get to that in due time. Patience. All right, it's time to have the talk. Every parent loves to have the talk. So here's the talk. Mongo has a special attribute called ID. Every document must have a unique ID in the collection. So 2 documents cannot have the same ID, but 2 documents in different collections can have the same ID. If you don't specify underscore ID, then MongoDB will do that for you. If you specify underscore ID, then that will be the document's ID. It could be whatever you want. It could be an int, it could be a string, it does not matter. Okay. The last thing I'll mention is you cannot take some column that you have in your document, like license plate or student email, and make that the ID. You must explicitly take the value that you want to be ID and assign it to the attribute ID. That's the way it works. So what this ends up doing is we end up having documents like this where we have an attribute symbol, and it's like, hey, Joel, I would love that to be the ID. That would be great. And then we have to copy that value again for ID. This is a pretty standard practice in the doc world. You don't want to not have symbol here and only have ID, because then we don't know what this is. Okay, so you want to have it in here so that, you know, the person retrieving the document knows that that's a stock symbol, and you want to have it here so that they know that this is unique in the collection. The fact that they're the same is just something that we decided as a programmer. It doesn't mean anything else other than that. The fact that you chose to use this is just your convenience. You don't have to. But if you do have a business key, and it does make sense to use a business key, like it's an ISBN or a SUID number, or, you know, a customer's email address, you know, that makes a lot of sense, especially for reference-oriented data. For process-oriented data, probably you want to use a surrogate key or some kind of timestamp if it's time series data. You want to always avoid building some kind of composite key, like out of like email and order number and this and that to create some kind of ID. That's not the way that you do things in the MongoDB world. It's just not. All right, so let's do another demo. Let's show you how ID works by inserting a couple more vehicles and then showing you what the ID attribute can do for you. Okay. Okay, I'm back out here at the MongoDB shell, ready to show you some more MongoDB goodies. So first and foremost, let's insert a document with a very specific ID. You do it like this: DB cars, insert one, and let's do a Honda because I have Honda here, and let's do what haven't we done yet? Let's do CRV. And let's put in a miles per gallon of like 20. And then I'm also going to add an attribute called ID. And I want that ID to be 1. I can make it anything I want. See, it says inserted ID 1. And then if I go here and let's just find all the Hondas. See, some of these Hondas, this Honda has an ID 1. This Honda has an ID of object ID. Okay, so now you got a ton of questions, I'm sure. But the first question is, what if I insert this again and change the miles per gallon to 21? Is it going to give me an error? Is it going to work? Remember, document databases, they just don't have a lot of data integrity constraints. The only one that they have a constraint over is you using the same ID twice. Okay? There you go. It says you can't insert. You've already got one. Duplicate key. This is about the only data integrity error you're going to see in a document database. This is it. Now, there's nothing preventing me from doing this, right? And then it goes in there twice. And I can't help it if it's kind of the same data. But again, that's 100% on the programmer's responsibility to do that right. Let's do another thing. Let's suppose I want to retrieve this document right here, this one. Well, you might think you do something like this, right? DB cars, find ID, you know. And then what's the object ID? That. Right? And I get nothing. And you're like, what the? Beep, 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 beep. What's going on, right? Here's what's happening here. This is a string. This is not an object ID. If you want this object ID, you gotta put object ID here. It's a very special value. Now I get it. Okay, so whenever you want to retrieve a document by its generated object ID, you need to use this object ID function to do that. All right. I can also retrieve these by just the regular ID if it's not an object ID, like we had that car that was a 1, right? What I can't do is I can't update a document and rechange its ID. Those kinds of things don't fly. Those are not options that you can do here in MongoDB. All right, let's talk about the other CRUDs in Mongo. How can you delete, replace, and update data? When you find documents and remove them with delete, you can do DB collection delete one or delete many, and then give it a query. You can also replace documents by saying DB collection replace one or replace many, and then putting in a query, and then putting in the object you want to replace it with. You can also do like partial updates with the update one or update many function query object, and in that object you're going to use a special variable called set to specify which bits you want to change in the document. So this is newer to MongoDB and allows you to do like some partial updates in the document. Very handy. All right, let's do a demo of all this stuff. We will show you delete one versus delete many. We'll delete by ID. We'll do a couple of replaces and a couple of updates. Okay, and then that will give you some good examples on how to manipulate data in MongoDB. Back out here at the MongoDB shell, I did a DB cars find, and you remember that I had this one in here named Mike, right? And I said I would delete it. So let's talk about how you delete this. To delete something, you have to match it to something. If I just did DB cars dot delete one, and then I just put this in, which one's it going to delete? I don't know. I guess we'll try that later on in the video. I don't want to try that now and lose all the stuff that I put in there. I want to delete this one up here, so I can use the key value pair to get it. I can also use the ID to get it, right? So let me delete this one by its key value pair. Name matches Mike. Now, if 3 of them match Mike, which one does it delete? It deletes the first one that it retrieves. Okay, so if I find, that one's gone. Let's delete this one by its object ID. I'm going to copy that because I'm not going to type that in. And let's do a delete one, and the object's ID is that. Okay, now let's do the $64,000 question. What happens when I delete one and it's Honda Civic? There's 2 Honda Civics here. See that? Honda Civic, Honda Civic. So what happens when I say cars delete one, make Honda model Civic? Which one gets trashed, if any? One got deleted? Let's find out. The first one got deleted. What makes it the first one? Well, in the collection, as things are added in the collection, if you scan through the collection, the first one that matches gets the axe. Okay. Ideally, you want to design your data or make sure that your data gets put into the document database so that it doesn't fall victim to this kind of situation. You want to make sure that doesn't happen. But, you know, that's just kind of on you to do. So if I want to get rid of all the Hondas, see, I got Honda, I can do delete many. I can say delete many and then make Honda like this. And that's going to get rid of 2 of them because there were 2 that matched this. So what I like to do when I'm learning this stuff is I might do a find this, and then, you know, that's nothing now. It's too late for that now. But if I do Chevy, if I did a delete many, if I change this find to delete many, all these are gone because they all match. Okay, let's so we did delete by ID, we did delete many. Let's do a couple of updates and replaces. So let's put something back in here to play with so it'll be at the bottom. Let's do cars, insert one, Honda, Now you see, it doesn't look right. See that? Like, why isn't this baby yellow? That should be an indication that you didn't do something right. Okay, and again, this has to be a JSON document. So, by the way, I'm hitting the up arrow, and then I'm just using the arrow keys. I want to avoid the mouse at all costs here. There. Now it inserted. Now if I just quickly find. Okay, now I can move on to my to demonstrating replace. Okay, so I want to do this. I want to say DB cars. And then let's do a replace one. And now I have to give it, first I have to give it a match. So if I want to guarantee it's going to replace the one I want, I could do Honda in this case because there's only one. But I really probably want to use object ID here to 100% guarantee that it's going to replace this. And then after the match, so this part is the match. Match. After the match, you put the new document. So I'm going to say make Honda model, and let's now change the model of this to Accord, and then let's say the MPG is 24 for good measure. And then this parenthesis closes out this one here, if I did it right. Okay, says it matched one, modified one, right? So let's go back and look, and now it's a Honda Accord. So that's how replace works. Okay, how does update work? Well, update is similar to replace, except it has this magic variable $set that allows you to specify which parts of the document you want to update, not the entire document. See, replace one is when you want to update the entire document. You want to just say, hey, you, get out, and here's your replacement. When you want to do an update one, let's pick on the Chevy Aveo does not have an MPG, right? Or the Chevy Traverse, it's lower down, doesn't have an MPG. Let's add that. So Chevy cars update one, and then we got to match it, right? So let's match it. Let's match it this way. Let's match it by its business key. Make Chevy model Traverse. I'll use single quotes this time. And then that's what I want you to match it on. And then what I want you to do as part of the update, okay, this is where it gets funky, is I would like you to set, and now you give it the keys and values you want it to set. I want to set, in this case, maybe MPG 18. And then I got to close that out. And then that. Then if I look, now there's an update. See, the update's a little easier than replace, because replace you have to have the entire object, right? By the way, this update one, you can add more than one, like MPG and then color, I don't know, white. See, I can add a couple of things in there. I can replace what's there. I can add things. It doesn't matter. Okay. How do I get rid of a key? Well, that's different. Okay. Now I can also use this update many to give every document in the collection a key. Like for example, I could do let's suppose these are all my cars because I'm just like so wealthy, right? So I could say DB cars update many, and then I want to match everything, and I want to set the owner attribute to Mike. Boom. All documents now have an owner attribute in there. Okay, that's doing the CRUD operations in MongoDB. Up until this point, we've been doing some pretty simple find queries, right? But there are ways to do more advanced types of queries. And one thing that we've been doing all along in our find queries is just using like the where clause, right? The query part filters, but you might want to do a projection as well. And there's a way to do a projection after the query in find. Like you look for all the Chevys, you might say, well, give me the models over here in the columns as part of that. So there's additional ways that you can manipulate find to sort of do your bidding. There are also these weird operators. We can't, because it's JSON, right? You can't use greater than symbols and equals symbols. Those things just aren't going to fly because it's JSON. So we have to use these special operators that begin with a $sign. So this is equals, not equals, less than, greater than or equals, less than or equals. And we have logical operators like and, or, not, in. And then we have null checks, like you can check to see if an attribute exists. Does the attribute exist? Exists true, exists false. Exists, doesn't exist, right? So we have a lot of different ways that we can sort of look for data in our document. Remember, everything's JSON. Column projections, sort functions, they all require JSON. So we have to give them this key value, like this, key value. But if you're just asking for columns out of projection, what the hell's the value, right? The key is obviously I want make and I want model, but what's the value? So what we do here is when we, like for example, this find says find, match everything, and then project these three columns, A, B, and C, and you must give them a value. So generally what we do is we say 1, 2, 3, and this gives us the ordinality. So this is the first one, that's the second one, that's the third one. So you see this a lot in MongoDB, and I just want to bring it to your attention so that you understand what this is for. I mean, they're all JSON, so because they're JSON, it's key value. This is key, the value is just the ordinal place of the column in the projection. Same thing with sorts. Collection, find, then I want to sort, and then I want to sort by column A, and then there's my value. Okay. If this is sort of like blowing your mind and confusing, this link is fantastic. It gives you, it's in the official MongoDB docs, and it says, here's what you're trying to do in SQL, here's how you do it in Mongo query language. You're trying to do this in SQL, here's how you do it in Mongo query language. And it's good for people like you and me that aren't 100% comfortable with MQL, but we know SQL, we know how we would do it in SQL and how we think about it in SQL, and then how do we go ahead and do that in MQL. It's perfect for that. Okay, let's crank out another demo giving you some advanced queries, things like that. We'll also do some combination queries and sort some output and stuff like that. We'll really get into to using Mongo to query data. So again, back at the Mongo shell, let's do some queries. So let's just, out of here, let's pull make and model only, right? Rather than pulling the entire document, let's pull make and model. So db cars, find, and then I want to match everything. And what I want to pull out of here is make as the first field, model as the second field. And see, what I get back are just the object's ID. You're always getting that back. And the make and the model. I don't get any of the other attributes that may exist in the document. Just, they don't come along for the ride. So let's do another example of this. Maybe you want to get, you want to find, let's suppose you want to find the, here's the makes and the models. Maybe you want to find the makes and the models if they have a mile per gallon, right? So I'm going to add to this MPG. just to set up this one. And you see, some of them have miles per gallon, some of them don't. I only want the ones that have a mile per gallon to show. So I only want these 3 to show. I don't want to show these 3, or these 2. So how do you do that? So you need to put something in here, right? But what you want to say is this attribute there? So the basically the way that you say, is the attribute there, is you say MPG $ exists. Everything's a key and a value, right? And then that's going to be true. I want it to exist, right? And I got a boo-boo in here because I forgot to match up. See, this one matches. This one matches that one, but nobody matches this guy over here. I forgot one more curly brace. Curly braces will get you. Okay, so now I only get back the ones that have an MPG. And this is very useful. Like, you might want to do an update only if there isn't already an MPG. Like, for example, maybe I want to set an MPG on the ones that don't have one, and I want to do it with an update many. I can use this to match when they don't have an MPG and then set an MPG. Okay, let's do a sort. So let's sort these by MPG. So let's go here, and then let's do .sort, and then we'll sort that by MPG, and that's going to be the first column we're going to sort by. And so now I've got 18, 24, 34, right? And before it was 18, 34, 24. All right, let's do an and. So I want them to have an MPG, and I also want the MPG more than 20, right? So that's going to be $ greater than, right? So it's going to look something like this. Like, first, let's do MPGs greater than 20. So MPG GT 20. And I need that second one right there. Okay, so these are the ones that have. Now, see what happens is if it doesn't have the key, it just doesn't get included. So maybe what I want is I want the MPG bigger than 20, or there's no MPG key at all. So I have to use the or statement like this. I have to say, I'm just going to take this all out. And here, I have to say or. Now, or takes a list. All the things in the list get OR'd. And I want 2 things to get OR'd here. One of the ORs is going to be the MPG exists true or false, doesn't exist. Wait. Okay, that matches that. And then the next one I want to do in here is going to be MPG greater than 20. I think I need one more curly brace there. Yeah. Hope to God this works. Okay, it did work. Wow, I am good. So you either do not have the MPG key, or if you do have the MPG key, it's greater than 20. That shows you how you can make some pretty damn complicated queries in MongoDB. And these selectors work with any. They work with find, they work with update, they work with delete, they work with replace. Okay, they work with all of them. So there's lots of different and unique ways that you can do this. Now, one thing we didn't talk about is how do you query nested data, but we'll do that in the next example, I'm pretty sure. Okay. Okay, let's talk about indexing. Indexing is something that we do a lot in document databases. Again, when you're storing all this data under pretty much one you're storing all these attributes within one document, you need to find a way to make it easy to query other things, especially when your collections are incredibly large. So you can use what's called a index to sort of rewrite the contents of the collection under a different key, and then that key ends up being hopefully beneficial to the types of queries you're writing. So what we will do here is we will use this create index to build out an index, and you can do this with one column or several columns. And this is where it's weird. It doesn't take a JSON document. It takes just several, column A, :1, comma, column B, :2. And then what we will do is we will show you how this works, and then also show you how to look and see whether or not your query requires an index, because that's a big part of writing these Mongo queries, is figuring out whether or not they actually necessarily need to use the index. Okay. One of the collections that's out here, it's not a shoe, it's a show, is called Europe. And that Europe collection got loaded when I ran the Spark code that I showed you earlier. And if I just do db Europe, find, and then this, you'll see that there's a lot of data in here. And that there's a lot of different data in here. So let's talk a couple of things, because there's lots of things to really sort of discuss, right? So maybe you want to get all the European countries and then get their French translation. See, that's under here, translations, French, right? So you might, and let's get their name, right? Because their name is in here, name. And then there's also their, where is it? Their region, their sub-region, right? So you might say, Europe find, and then in here you might say, give me all the documents for now. And then you might say sub-region or name. Name is one of the things I want. And then sub-region is the other thing I want. And then I also want the French translation, right? So I also want translations, French. And that's the third thing I want. I think this is the way to do it. There's one of two ways to do it. It's either this way, or it's with the dot operation. We'll find out. Oh, there we go. See, that works. See, I got everything I wanted. I got Finland, Northern Europe, and then I got the French translation of that. Okay. And there's a lot in here, but if I show you my query again, right, you're just going down through the nested attributes in the document to get the bits that you want. That's basically how that works. Now, you might look at this query, and let's add a filter to the query to make it indexable, right? There's no benefit to indexing this because you're not asking to retrieve by a key. You're just projecting columns. But if I say, you know what I'd like you to do? I'd like you to give me the sub-region of Northern Europe. I'd like you to give me that. Okay. Now I have a filter in here, right? See, I'm just asking for that. So this is acting as a key. So whenever you have something acting as a key, we've learned that maybe you can benefit from using an index. So let's see how we can sort of figure that out. So here's my query, right? I can add a dot explain to this. And then I need to ask for the execution stats. Actually break this up do that dot explain and you'll see in the execution stats, right? Here's the explain, and then this tells you what's happening, right? And it says it's doing what's called a col scan, which you might think is a collection, is a column scan, but really it's a collection scan. So what that says is it's for looping over the collection. It's saying, are you Northern Europe? Yes. Okay, well, I'm going to add you. Are you Northern Europe? Yes, I'm going to add you. Are you Northern Europe? No. Well, I'm not going to use you. Are you Northern Europe? No. Well, I'm not going to use you, etc. It goes through every single document in the collection. Now, you might say, well, that's not bad. And in this case, it's not, because there's only 53 documents in the collection. See that? There's only 53 documents in the collection. That's not bad. If it was like, I don't know, 53 million, this might take a while. Especially if there's only 4 regions in Europe, Northern Europe, Southern Europe, Eastern Europe, Western Europe, yet there's 53 million docs. And this would be a good index candidate. So let's, for fictitious sake, build an index candidate, or build an index, and then see how the same query that we wrote here benefits from the index. So let's do DB Europe, create index, and let's put that index on sub-region, and that's going to be the first and only field in there. Okay, and then I go and do my find again, and now you'll see that I am doing an index scan instead of a column scan. Okay, I'm doing an index scan instead of a column scan. And let's see, the number of documents that were returned is 16. So I don't have to look at all 53. I only have to examine 16 documents, because the index tells me which documents I need to retrieve. And so then I just get those documents, and I don't have to go ahead and try to traverse the entire collection to figure that out. So when I run this, it's now using the index. Again, there's not really enough data here to do that. But again, if you're going to be a big data person, you really need to understand indexing. And indexing is incredibly simple. What you're saying is, I want to search for this. Therefore, rather than using ID as the key, I am going to use this as the key. In order to do that, I need to create an index like this. However, when I make an index, what am I doing? I'm rewriting the data again. Okay, so that's why there's a limit to the number of indexes you can create per collection, because every time you make an index, it's making a shadow copy of the data in the collection. It's reorganizing some of the data in the collection so that it's much more easily searchable by this attribute here. Okay. What do you include in the index? You want the index to cover what's in the query, but you don't want to include multiple things in the index in hopes that they'll all cover something like this. You don't want to do this. Okay, you only do this if you want to search by this and this. Then you would create an index with 2 columns. Okay, you're going to make an index. Indexes, as I like to joke, are special snowflakes. Okay, the index solves exactly the query need you have, nothing really else. Okay, that's just the way it works. What's different about these indexes as opposed to relational database indexes is you do not need to include any columns. These indexes are really just creating a mini collection, if you will, of each of the different subregions. And then in that is a list of the object IDs, so that it first has to collection scan the index collection. Then once it finds Northern Europe, it then knows where to seek to get each of the object IDs. It no longer needs the for loop over the original collection to get to the object IDs. That's basically what's going on here. But again, understanding indexing is so important to big data, because we need to improve the performance of the query process. And again, storage is cheap, so why not have a couple of indexes out there? Why the heck not? All right, let's take a look at how Drill works with MongoDB. Drill has a storage provider for MongoDB. It treats the collections as tables and documents as table rows. It's very familiar to you because it works a lot like querying JSON data that exists maybe in Hadoop, or maybe exists in MinIO, or maybe exists in the local file system. It actually takes the same kind of behavior and patterns. And so it's a very nice way to query the data out and not have to use MQL. If you can use MQL, use MQL, because that is going to be the most efficient way to get the data out. Think about adding these extra layers in there. That's always going to be a little more problematic. All right, let's do a little quickie demo here where we just go out to Drill, get it configured, and then maybe run a little select statement over those European countries. Maybe we'll do the same query we just did. Okay, here I am out in Drill. Let's go to storage. I might have had this already set up. I don't think I do. So let's go over here to Mongo. And it's really easy to set up Mongo. All you need to do is put in the connection to Mongo. So in here, it's going to be our server name inside of Docker is Mongo. So, but I also need to give it a username and password. So it's going to look like this. It's going to be admin as a username, and the password is Mongo PW. That's the password. And then the server is Mongo, and then that's on 27017, and we're authenticating with the local database, which is admin. That's basically how you set it up, just like that. And then I'm going to enable it. And now I should be able to query things under Mongo. So let's see if this works. Select everything from Mongo. And what's a database that I had there? I had a database called Demo, and then a collection called Europe. And it's grinding away. Maybe it'll work, maybe it won't. We know how Drill is. There it is. Okay, so here's what happens when you take those object IDs and they get deserialized. It's just a series of bytes. The /b is for bytes. So this is like completely incoherent. But then here's all the columns that were in the document. And if you go around, you can see that some of these are nested. And that's all right. But where this ends up being very useful, by the way, is, when you're trying to do aggregates and things like that, those kinds of things are tough to do in a document database, but very easy to do in SQL or Spark, right? So this is where it ends up being very handy. The thing that's kind of like ugly about Drill, again, is you really can't see a schema here. So you're kind of like shooting at the hip here, trying to figure out how to do this. So let's try to do something. Let's do like country name, subregion, and then what did I have before that I did? And then what did I do over here? I did translations French, right? So in Drill, that's going to be trans French, like that. I think that's the way to do that. I hope. Okay. It didn't work. Let's try that. There's my translations, FR. Okay. Maybe I didn't do something right. I probably didn't, so it's probably all my fault. Everything's my fault. And that's not That's not jiving. I wonder if I got a back ticket. Oh, yeah, you can't. See, it's drill staring me in the face. You can't do this without aliasing, right? I forgot this. So E, and then I got to go E name. Yeah, see? Get you every time. There we go. Same thing with like nested values, right? Like that are in lists. I can get those out with explode. All the things you already learned, they all apply. Once you, again, the thing with drill, once you can get the storage plugin working and you can actually touch something within that target database, you're good to go with drill. All the drill you learn still works. And all the SQL you learned from the previous course applies to drill. Okay, let's talk turkey on the Spark connector. So, MongoDB has a Spark connector, and it supports pass-through, which is really nice. The way pass-through works, a lot of these databases and their support with Spark does this. And basically what happens is you apply some kind of filter. You use the filter command in Spark or the where clause in Spark SQL, and that is passed to MongoDB, where MongoDB does the filter, and then what you get back to Spark is a smaller set of data. So where any of these pass-through connectors can do this, they will take typically the where clause and the column projections in the from clause at minimum and apply those in the target database. So for instance, if I just asked for Hondas and I want miles per gallons under 20, those two criteria would be sent to MongoDB by Spark at execution time, and then all MongoDB would give back is a smaller set of data, and then Spark would in turn continue the manipulations on that data. So this is incredibly efficient and incredibly big data friendly. What we want to avoid doing is lifting all the documents out of the collections and then putting them into Spark. That would be a bad idea, right? We don't want to take 53 million documents out of Mongo and then load them into Spark. That is not, you're going to have a bad day, right? So this is way more efficient than just grabbing the entire collection. That's exactly what we're trying to avoid. So how does this work? The Mongo connector includes data frame support through the custom format Mongo. And you're going to see that all of these databases that we will learn have a custom format. And as usual, there's a ton of configuration options. You can go to the URL, click on it, and read through all the different ways that you can manipulate the MongoDB connector to do your bidding. So here's an example of a read, right? So you can say Spark read format Mongo. So, if this is some other database later on in the semester, it's going to be read format that other database. And then these options are now specific to that format provider. And we've seen this before with CSV or JSON. There's different options. And the minimum options you need are the database and the collection. And you notice you can't pass an MQL query in here. That is handled for you by the MongoDB connector. The MongoDB connector looks at what you're doing in Spark/Spark SQL and figures out amongst the directed acyclic graph that Spark produces what kind of business it can pass on to MongoDB to do for you. Okay, here's an example of a write. You have your write format and then your mode, append, overwrite, error if exists, and then which database and collection you want to write to. And that's basically how reads and writes work. Let's finish up the unit with a little demo of this. We will load that European country into MongoDB. As you also saw, there's an example of that, but now we'll sort of look at it. And then what we'll do is we'll write some basic transformations and look at the explain so that you can see that the filter is happening in Mongo and not in Spark. And this is what that pass-through filter is all about. So that's really what we're going to emphasize here in this demo, not necessarily how to read and write things from Spark. That ends up being kind of trivial. what's important in most of these connector demos is understanding what makes that connector different, how that connector behaves. That is the big data mileage that you need to sort of get out of integrating databases with Spark. Alrighty, for starters, this is basically the boilerplate to connect to MongoDB, and we sort of looked at this earlier, but again, there's my URL. It's very similar to what you saw in Drill. And this is me asking for the Spark connector for Mongo. And this is where I read and write to Mongo. And those are the global configs that you have to set for the Spark session. Once the session's set up, you can read and write. And these lines of code, this is just reading in the stocks data. This is reading in the Europe data and then writing it right back out to a MongoDB collection, overwriting it. And then this one's doing the same for FudgeMart products, and this one's doing it for the Senators collection. And we'll use these probably in the labs and homework. So I'm going to run those. And what those end up doing is those end up making, in the demo database, you're going to see that there's some collections in here. Senators, products, Europe. Those are all made when you run this code here in Spark. Let's get down to what really matters, though, understanding what the connector is doing and how it's different than just regular old Spark. All right, down here at the bottom of the Spark document, I have some code that reads from the local file system, that Europe file. And then this one reads from Spark. I'm sorry, it reads from MongoDB. So I have one data frame called local Euro and another data frame called Mongo Euro. And then I'm going to write the same query. So local Euro, give me the Alpha 3 code, the name, the subregion, and the population. And why don't you denormalize the borders and alias that as borders. And then let's filter that on a subregion like Northern Europe, right? So I'm going to get a list of countries and then a list of their borders, and it's only going to be for Northern Europe. And I'm going to do that for local and Mongo, and then I'm going to show both, right? And let's just stop there for now. I'll comment these out. I'm going to run this, and when I do, I get back, like here's Denmark. It's in Northern Europe, and it has this population, and it borders Germany. And if I go down here, I have Finland, because it borders Norway, Sweden, and Russia. So that's basically the table that we built from the document database. This one is local. It just reads a file. This one is from MongoDB. The question is, how are they different? So let's turn on the query explainer, which will show us the graphs that are built. Okay, the first graph, this is the local file, right? It does a file scan. That file scan is passed into Spark, and then Spark is doing a filter, right? On subregion Northern Europe, and a bunch of things are not null, and then it's doing a column projection. Let's compare and contrast that to the same data frame, but the data frame is not pointing at a local file. The data frame is pointing at MongoDB. Right, if you look here, it scans the Mongo relation, right? And then in here, there's what's called a pushed filter. See this? Pushed filter. And it's asking for the subregion equal to Northern Europe. So it is actually sending that filter to MongoDB, and MongoDB is saying, okay, only give me Northern Europe. If I look through here, there's probably a place where it's only accessing certain fields as well. If I look through here, these are all the fields, but there's this push filters, and there's this read schema here says only give me Alpha 3 code, borders, name, and subregion. And this is, again, this part here is only asking MongoDB for that data, and then that data is coming back, and it has this filter and projection, and the filter here is still there, but the data is a lot less unwieldy as opposed to this one. So that would be the benefit, if you will. If you're trying to figure out, well, why would I ever use a document database in Spark when I can just read a JSON file off of S3? The advantage is the query processing that the document DB does can work for you in those cases, as opposed to when you're reading it off S3, you've got no choice but to take 100 gigabytes of data that is a JSON document and load it all into Spark. The advantage of using MongoDB is if you do have a filter in there, MongoDB can try its best to limit the amount of data that ends up getting sent to Spark. And that's basically how that Spark connector works. Okay, let's sum up. Document databases are general purpose and support entity relationship models. You can really read and write any kind of application you want to a document database. It is not a very special purpose kind of database. It's very general purpose. So it uses the JSON schema to save data. Any data can be written to any collection. It does not have to enforce the schema that you use. It's not how it works by design. This is good and bad. The bad part is you can write whatever you want to wherever you want. It just doesn't care. The good part is you can write whatever you want wherever you want. And it just doesn't care. So it's incredibly convenient. MongoDB supports high availability through sharding and replication. Shards are partitioned documents within the collection. The shards are always based on the ID, by the way. If you specify the ID, it will shard based on that, but you can also specify a strategy by which the shards are split. MQL is a JavaScript-based query language, and it has full CRUD support for MongoDB. It's worth learning MQL. I know it's not easy, but with each of these databases that we're going to cover in this course, you want to take the time to learn how to query them natively. Even though you can use Spark and Drill, you do need to have some degree of understanding of how the native query language works in each of them. MongoDB supports indexed collections to improve searchability, and this is incredibly important in document databases where we have a lot of nested data. And there's drill support for MongoDB, and there's Spark support for MongoDB, and more importantly, it supports pass-through transformational logic to the database. So any sort of column projections or row filters, those would get processed in the MongoDB database and not in Spark. And this saves on a lot of data moving over the network, and it also saves on compute resources.